So, hello again. My name is Przemek, as Tomasz has introduced me, and this presentation is titled "Practical Contract Testing in PHP." Let's see what we will learn today by listening to my presentation. Firstly, we will learn about contract testing itself, what it is, how it can be done, etc. Then we will talk about what is Pact and what Pact's place in contract testing. Then we will hopefully learn how to use Pact in PHP. I have prepared some sort of a short crash course. We'll see how it goes. And then we will talk about benefits of using Pact. There is also a small side note that we will be explicitly talking about REST HTTP APIs for communications between our applications, but that is by any means not the only way we can use and not the only way Pact actually supports. But I've decided to only talk today about REST HTTP API for simplicity's sake. So first, let's talk about a bit about contract testing. What is it? Well, probably everyone knows what a contract is. Well, not a contract between microservices, but a contract in a word, like you sign contracts with your employers, something like that. And also we can consider the parties which interact with each other in a communication between some applications, also sides of a contract. So in a API integration, those two sides, those two parties will be called the provider and the consumer. This terminology may be familiar for people who worked with, for example, queues like RabbitMQ and something like that. So the provider, as the name suggests, provides some sort of service. For example, it provides us with the REST HTTP API. The consumer will be the application which interacts with this API. And both of those sides can produce a contract. For example, a contract can be an API documentation, like an API documentation prepared using an OpenAPI standard readable by Swagger, or maybe created by Postman, or maybe even a set of recommendations, set of expectations prepared in a Jira task or something like that. Those can be considered contracts. And well, if both of those sides can describe how the API integration should look like, for example, the provider team can document their API, the consumer team can document a set of expectations. So maybe if both of those sides know what they would like to expect, maybe we can turn those expectations to a set of requirements which we can use to test if both those sides understand each other correctly. So that's the point of contract testing. We can ensure both sides of this equation are compatible with each other without them directly interacting with each other. We'll talk about benefits of it a bit later. So I will go through a set of tools I've personally worked with to perform contract validation. This is by no means an extensive list and probably not even the most proper one. This is only a list of tools I have personal experience with and can share some thoughts about them. So the first thing I have dabbled in using was Swagger CodeGen. This is basically a tool which can generate SDK libraries based on a documentation for API written in Open API standard. So if we have a contract written as an Open API documentation, we can automatically generate tools to interact with API like this, and we can use it to automate our testing process. This can be done, but of course, Swagger CodeGen is not directly a testing tool. So implementing it to a testing framework, testing pipeline requires some hassle. So it's not the best way to use it, but it's doable. But of course, it has one other downside, and I will talk about it when discussing the next tool, which is Postman and its companion application, Newman. Probably most of you have used Postman or are using Postman still. I think it's a wonderful tool which can be used, of course, as an API documentation, which is readable both by developers and non-developers, and also can be used as a testing tool, not only because you can actually run requests using this tool, but also you can write some tests. Like, for example, you can define that this interaction will return HTTP status code 200, write assertions on it, etc. This is a tool which is kind of more usable, but it also has one downside. But let's talk about flow and how can we use it. So, for example, as I said before, both sides of the equation can prepare the contract. In this example, I've decided to go with the consumer team preparing a Postman collection, which can be defined as a contract. And it will, of course, include tests. Then, when we have this set of expectations in form of this contract, the provider team can implement their application. So it will conform to the contract. They can test this application by running the collection prepared, for example, by using Newman, by integrating it into their continuous integration process. And, well, if everything works as expected, every test passes, we can be sure that the provider has successfully verified the contract. It's 100% compatible. So basically, that's a form of contract testing. But it has a little downside. Let's consider if both of those sides really verified the contract properly. Are both of those sides, the provider and consumer, are conforming to the contract? So we've tested the provider, right? We've taken the collection, we've run every interaction, we've tested everything, all tests are green. So with some leeway, we can say that yes, we have successfully verified the provider and the provider conforms to the contract. But what about the consumer? Well, as in the first line, the consumer team has written the contract. So probably if they are the source of the contract, they conform to it. Not exactly, because writing a Postman collection is kind of a outside task of coding the consumer application itself. So we don't actually know in normal circumstances if they are actually using the thing they've described the way they should be using. So we don't actually know if the consumer side is really verified until we check it. And that's where Pact goes in. I think that from the solutions I've personally tested, this is the one that actually ensures that both sides conform to the contract. So let's go and talk about Pact itself. Pact is by definition consumer driven. So the consumer is the source of the contract. it doesn't mean that, for example, the provider development team has to wait on the contract and doesn't have anything to say and has to implement, some things they don't like. No, the business process can be anywhere, anything you like. You can discuss it. You can do meetings, Jira tasks, Slack conferences, etc. But technically, in the technical process, the consumer will be the source of the contract. So let's go with Pact itself. What is Pact? We can talk about Pact in two contexts. If we talk about contracts and pacts, let's say contract is the more broad word. So many things can be considered contracts, like documentations, expectations, etc. Pact is a more specific form of contract. Pact will be basically a JSON file with a specific schema which defines the interactions in an API. Pact can also be considered as a set of tools, and I will talk about those tools right now. So the most important tool in Pact is mock server. The mock server will actually represent the provider with interactions with the consumer when writing the consumer tests. How it works, I will show you in a couple of minutes. The next tool is a Pact broker. The Pact broker is basically a standard of storing the Pact files. So it will be an HTTP server, which we use to store our pacts, download them, and inform if they are verified or not. The Pact broker client is essentially a library which we use to interact with the broker. The Pact provider verifier is a tool which interacts in turn with the provider. We use it to verify if the provider application actually conforms to a contract. All those tools are distributed as binaries, Docker containers, if we prefer using them that way, and also some language-specific libraries, like, for example, for PHP, which sometimes are wrappers for those binaries and containers, sometimes have some additional stuff which can be useful for developers. And I would also like to talk a couple of minutes about Pactflow. Pactflow is a separate tool. It is a commercial Pact broker implementation, because Pact broker, as I said before, is a standard. Pact Foundation produced Pact as a set of open source tools, but Pactflow is their commercial tool, which we can use if we want to, but it's a nice to have feature. It has a web interface when we can browse our API documentation. We can browse all contracts, interactions, versions, because yes, contracts are versionable, and also we can produce a nice looking service diagram. Well, this one is not particularly nice looking. It's a bit cluttered. But if we, for example, hover over one of those microservices visible in this diagram, the others will be grayed out, so we can see directly with which our currently chosen microservice interacts with. And also it allows us to create some webhooks that can be useful, for example, to make some sorts of notifications where when we have a new contract uploaded to the broker, or maybe a new version of a contract, or maybe some verification fails, we can use those webhooks to, for example, set up Slack notifications. Okay, so let's talk about how is Pact used in contract testing. So as I said before, we start with the consumer. The consumer team, the consumer development team, writes API tests. By using Pact consumer library, during writing those tests and running them, a contract is produced in the form of a Pact file. Then this Pact file is published, or maybe many files, is or are published to a Pact broker. And that's basically the consumer side done. Because when the tests pass, using Pact consumer library, we can be fairly sure that consumer conforms to the contract it has written. How? I will describe this process in a minute in more detail. Let's go with the provider side of the things. So the Pact verifier, which will be used on the provider side, downloads the contract made by the consumer and then runs it against a provider instance. And performing those interactions, which are contained in the consumer contract, it verifies the contract. Then it publishes the verification status to the broker. Well, it can be, of course, success or failure, depending on the actual verification status. On a side note, the part highlighted in green, I can say it's optional, because using Pact broker is kind of not really required, because, as I said, the Pact contracts are essentially JSON files. We can distribute them. We can distribute them any way we want to, by storing them in a network drive, in the cloud, sending them by email. But I personally recommend using Pact broker because it has some nice tools and features, and also interacts with the Pact provider verifier nicely. Okay, so I've said that the contract is generated by writing tests, but how does it work? How it's done? Okay, so we have our two sides of the contract, those two parties, like consumer and provider. So if we want to write integration tests that will communicate with the provider, we will need a provider instance, or maybe not, because as I said before, we would like it to be tested in separation. So enter mock server. The mock server will take place of the provider, but right now, out of the box, it doesn't really know what to do. So when we write our test, we begin with describing the interaction we are expecting of it. So we will describe what request we will send to it and what response we would like to receive. That way, we will describe an interaction which will go into the contract. Then, of course, because we are testing, we perform the actual tests. And during performing these tests, we will actually perform the interaction because, for example, the service being tested will try to communicate with the provider. Then the mock server will validate the interaction. It will check if it was an interaction it was expecting, and if it was, it will check if everything is as expected. So, for example, if the payload is correct, if the HTTP headers are correct, or if the URL is correct, etc. Regardless of the validation status, it will return a response. If everything goes as planned, it will return the response we described in the first step. If something fails, it will return an error response. Then we can run our assertions. For example, we can check if the response is actually the one we expected. If not, well, something is wrong. And also we can test any side effects we want to. Okay, so that was the theory. And right, let's put it into practice. I've described this as scratching the surface because basically writing contract tests is a kind of complex process, has some caveats which we won't have time to delve into, but I've prepared a small live coding session for you when I will produce a contract and hopefully verify it on both sides. So let me switch to my PHP Storm. I hope every one of you can see it correctly. And I will start with this interface. So let's consider this example. We will have two applications. But for the purpose of this presentation, there will be only one. But for example, there is a provider which has information about some products, but it doesn't have an API. And we also have a consumer that would like to get information about those products from the provider. So what do we do? Well, we will have to write a contract between them and implement on the provider side the API, on the consumer side a service which will interact with this API. Since we are consumer driven, we will start with on the consumer side and write this service. So basically what we would like to do is to implement this interface, this port, right? For keeping things simple, I have prepared a small class, which I called Guzzle Products, and put it into the infrastructure layer because we will use the Guzzle HTTP client to interact with the API. Now you'll get a glimpse to my test-driven workflow. So the first thing I would like to do when I have an empty class like this is to write a test, because we are talking about in the infrastructure layer. I think the most sensible thing to do will be to put the test in the integration tests. So this is an empty test case I've prepared, but we will swap the default PHP unit test case with something called Pact test case. This is a small convenience class I have prepared specifically for this presentation, and you all will have access to it because all of my files for today are open source. I will share the presentation and the files with you afterwards. So let's write the test. We will begin by specifying a test method, which will, for example, be called should get all products. As I said before, the first step will be to tell the mock server how should it behave. So we will use a convenience method from the base class called mock interaction. And to this method, we will pass some data about the request and the response. I will format it nicer and okay. So let's describe the request. It will be a GET request. And for example, let it be to a path / products. Why not? Okay, that's all we need for now. Now let's get to the response. Let's say that we would like status to be nothing fancy, an HTTP OK 200, and the body. Well, let's go with the JSON API standard. In the JSON API standard, everything have to be wrapped in the data key, and we will have an array of products here. So we will require a type. The resource name will be products. We will require an ID. For example, let's be an integer ID. And also we will require some attributes. Let's go with a name. Let's call it an awesome product. And that's everything we need for now. I am using arrays here to specify the requests and response attributes, but Pact itself is object Pact PHP library itself is object oriented. This is only my wrapper, my simplification for the sake of this presentation, so everything can be readable and visible on one screen without the need to browse between more classes. Okay, so this test obviously doesn't do anything good right now, so let's test it. We will need an instance of our service, so let's create it. Let's retrieve the products. And if we want to test anything, let's give it an assertion. For example, we've specified that it will return one product. So let's check if we actually receive one product. Okay, what do we have here? We have a test. Let's run it. No surprises here. It fails because we actually didn't implement anything right now. So, but we see two tests failed instead of one. The reason for this is, well, our assertion failed, or maybe even not our assertion. We failed because we aren't returning anything from the service, but also we have failed because the mock server didn't actually receive the request we specified before. So the class, the base class, does this check. It checks if the mock server has received all interactions defined. This is one of the most important parts of checking if the consumer side conforms to the contract. Okay, so let's get to the implementation. I will do a heresy. And if I can say a disclaimer here, don't try this at home. And because we will create a client in the constructor, for simplicity's sake, let's say that it will be done the proper way in the refactoring process, which is the third part of the test-driven development process. Basically, the proper client should be injected by dependency injection. But for now, let's stick with this heretic stuff. Let's specify the base URI here. And the base URI will be, also for convenience, I will use the configuration for Pact. Pact host and Pact port. As I said, in a proper application, in a proper way, a proper client will be injected by dependency injection. So we will receive in the production environment a client which will call the production provider instance. In the testing environment, we will receive a client which points to the mock server. So let's actually return our products. So let's do it this way. this client, of course, we would like to do the get method, communicate with the products endpoint. We would like to get the body and the contents. Of course, string, and it's JSON encoded. So let's decode it. Into an array. Let's harden the errors handling. And of course, if you remember, it will be wrapped in this data key. So let's unpack it. Okay, this is our really basic and error-prone implementation, but it probably will work right now. So let's rerun our test. And it works. Okay. So what we have done here right now is basically we have produced a contract and verified. But why? How? We can switch to this file, and this is our contract, which was generated by us running those tests right now. This is the Pact format. So it provides us with the name of the provider and the name of the consumer. Also, it provides us with an array of interactions, and it goes with some metadata. So this is a description of an interaction we will expect. So that's one point. That's one part. We have using one process generated the contract, and we have ensured that the consumer is properly verified with this contract. But that's the one part. Let's go on the provider side. So what will we do right now? Maybe we will do it this way. We can go to the command line and use the Pact provider verifier binary. Let's pretend our application is now a different application and it's really a provider somewhere. So we will do Pact provider verifier. We will use our Pact, which we generated right now. And we also will have to specify where does the provider reside. And in this case, because we are using a Laravel application running on PHP development server, it will run on this address. So let's run the verification. And of course, the verification failed. Oh, and it failed because connection was refused. As I see correctly, as I see, I have typed an incorrect port. Okay, right now we have a different error message. Basically, what it tells us is that we have received an 404 not found HTTP status, and this mess under it, it's because we have received the contents of the 404 standard error message. So not really what we expected. We expected a list of products and the HTTP status code of 200. So let's implement it. Let's do it in a really simple way and hard code it so we can verify the contract. So we will need a get root / products, and we will do it really by simply hard coding it. We will return a new JSON response, which will contain, of course, as we specified, data and a list of products, which will have the type of product, an ID, and also some attributes, specifically the name. The awesome product. Okay, let's format it a bit. I think it looks good. Let's try this again. And now we have very successfully verified the contract. So we now have two sides which conform to the contract. Using this simplified procedure, we can actually right now know that both of the sides will communicate correctly with each other. So we can do both of those parts of flow during separate continuous integration processes for both the sides, for both consumer and provider, and without them actually interacting with each other in some kind of development, testing, staging, sandbox environment, we will make sure that they are correct. But that's not the end. There are some caveats here I would like to mention. For example, right now, the contract we have written is actually a bit too strict. If we return another product, which will have ID2 and will be more awesome, if we try to verify it, it will fail because we get some some unexpected stuff, right? Because we specified only for the API to return one product. So let's fix that before moving on. We can use a tool called Matcher, which is a part of the Pact PHP library. And we can replace the array of our products with matcher each like. By rerunning the test, we will regenerate the contract. We can check it right now. And as we can see, it produced a thing called matching rules. Right now, it will match if the data is an array, and also it will check for only for minimum instances of elements in this data key. Right now, it requires minimum one product. So it looks better, right? So let's maybe try and verify it again. Right now, we are good to go. There's also a small thing right now I would like to address. There are some things we should also replace with matchers. For example, we should make both those things more loose. So right now, we will have more matching rules. And we will be matching the ID and name by type. So it will validate if the products returned by the provider conform to the specification only by type, but you can use more strict matching, like, for example, using some stuff like regular expressions or something like that. One more thing I should mention is that we didn't actually test for headers, but you can do it. It's fairly simple, but as I see, we are running out of time right now, and I have also some more stuff to say about the theory, so let's put a lid on it right now. Okay, so that's basically how we can do our contract testing using Pact. But as I said, it is only scratching the surface because this is a more complex problem and requires a couple of hours more to learn properly. So let's talk about some benefits of using Pact. Well, as I said before, we are testing both sides, both parties in isolation of each other. The main benefit to it, I've pasted this beautiful microservice diagram. If we would like to, for example, without contract testing, run some integration tests on a development environment, on our local environment and something like that, it will be probably a really hard task. Of course, it is doable, and there are other tools to expedite it, like, for example, setting up some sandboxes, connecting to a well-prepared environment, but frankly, a lot of hassle. If we can test all of those in separation of each other, it will be, well, easier and frankly speaking, less error prone than setting up all those testing environments. Oh, and I've forgot to mention, you can also use pacts to mock external dependencies, like external APIs. Basically, you don't need to verify them, but it will kind of simplify the flow if you can make contracts for both your internal applications and your external partners. Okay. The benefits: the contracts are generated automatically. So when we write our tests, when we write our specifications for the mocks, the contracts are generated automatically. They conform to a standard which is readable and readable by tools. So that's one of the benefits. And also, if we use the Pact broker, the contracts are also used to automatically generate API documentation. Of course, we can use it in our pipelines. We can use it in our continuous integration processes. So if our build process fails, we can be also informed about it during our contract testing. And also, a failure of contract is not necessarily a bad thing, because let's think about different versions of applications. If we have to maintain many simultaneous versions of our applications, the contracts can help us distinguish which version is compatible with each version of another application. Okay, so a small recap. What have we learned? Well, we've learned a bit about contract testing and different ways to implement it. We learned about Pact. What are pacts? What tools is Pact made of? We've scratched the surface about writing basic tests using Pact, and we've learned about some benefits which are not limited to the ones I've said. And okay, and there are also a couple of things we didn't have time to learn about because, as I said, it's a complex problem. Managing interactions with multiple providers, it is simple, but requires a bit of a hassle with configuration, but it's doable. Using provider states. You can think about the provider as a state machine. Sometimes you need it to be in a specific state to test it. For example, in our example from live coding, we kind of required the products to exist. There also can be a state when we will require the products not to exist. Setting up provider states is one of the more complex and I think the hardest task in working with Pact. It requires an own presentation on it. Also, we didn't learn how to set up continuous integration with Pact, but it's doable. but everyone can use their own ways to do it. There is also support for versioning. As I've mentioned before, all pacts are versioned, and we can use those versions to check which versions of our applications conform with each other. Also, non-HTTP communication, as I've mentioned before, Pact can also be used in any types of integrations, not only REST HTTP APIs. So that's all for me. There is some contact data I've included in the presentation, and also a link to the presentation. I will, of course, share it with you after the presentation. So that's all for me. Thanks, and let's get back to the studio.